Thank you, Hans, for the introduction, and good afternoon, everybody. My name is Wim Boone, working for DNV-GL, and I would like to give a presentation with the main title, Copper or Aluminum? That's the question. The subtitle is Copper in comparison to aluminum as common material in conductors of low voltage and medium voltage cables, talking about properties and related decisions. The main title, Copper or Aluminum, that's the question, is a playful reference to William Shakespeare, and I would like to say a few things about that in a preface. William Shakespeare, well known, he lived many years ago, and he wrote many acts. One of them is Hamlet in about 1600, so more than 400 years ago. Then the young Prince Hamlet, that is one of the main actors in that play, was depressive. He was in an existential crisis, observing that good things are overruled by unexpected disasters. And then he said in Act 3, Scene 1, to be or not to be, that's the question. It's the most quoted verse ever. This mild parallel with the present presentation is that copper, an excellent material, is not validated as it should be validated, but unilaterally subordinated to aluminum on initial costs only. This is my table of contents, the issues I will discuss in my presentation. First, an introduction. Then I will say a few words about the typical differences between copper and aluminum, resulting in pros and cons of copper versus aluminum as a conductor material. I will talk about failure mechanisms. I will talk about the questionnaire we sent to about 100 utilities with questions about the use of copper and aluminum, and in particular, how they select the right material. We will talk about the decision makers. What process is happening when somebody makes a decision to select copper or aluminum. A few opportunities for copper, and finally, conclusions. This time to be followed by a few statements we are going to vote on, but that is at the end of the presentation. The European Copper Institute, ECI, asked DNV-KEMA, now operating under the trade name DNV-GL, to investigate the position of copper versus aluminum in the application of low voltage and medium voltage cable conductors. DNV-KEMA investigated the literature about typical properties of copper versus the properties of aluminum. We also investigated the literature on the typical failure mechanisms of cables and accessories related to the conductor material. So is there a link between a failure and the conductor material? We prepared also a questionnaire, and that was sent to about 100 utilities in 25 countries. The questionnaire consisted of 3 parts, of which in this presentation only the third part about the decision model, that means how to select copper or aluminum, will be dealt with. In this presentation also information will be given about typical properties and the decision model, how to select the conducting material, copper or aluminum. Talking now about the typical properties of copper and aluminum. Copper has a higher specific conductivity. Copper also has a higher specific weight. For equal conductance, the cross-sectional area of aluminum has to be increased by a factor of 1.6 compared with copper. In other words, for the same resistance, aluminum conductor is larger than copper, has a bigger conductor radius. For equal conductance, the weight of aluminum conductor is almost half compared with copper. So for the same resistance, conductance, aluminum conductor is half of the weight of copper. Copper has a higher tensile strength, higher elasticity modulus, and a lower coefficient of expansion. Copper is far less sensitive for corrosion. This is a very important difference. Aluminum is corroding quite rapidly, and copper is not doing that. For a more quantitative comparison, I would like to show you the next slide. Here, I've given copper the value of 100, and then the other value is given in a relative scale. Well, first the electrical resistivity. When copper is 100, aluminum is 164. The density is going the opposite. When copper is 100, the density of aluminum is 30, so much less in weight. When you look to the weight in relation to the unit resistance, then you have the values 100 and 53. And when you look to the diameter in relation to a unit resistance, then it's 100 and 129. The elastic modulus, when copper is given the value 100, for aluminum 55. Hardness, copper is 100, aluminum 44. The ultimate tensile stress, when you take 100 for copper, it's 35 for aluminum. The melting point, 100, then aluminum is 61. Stress, fatigue, endurance limits, 162. Thermal resistivity, 100, 158. About the corrosiveness, we couldn't fill in values. We just said copper is resistant to almost all organic chemicals. And secondly, aluminum may corrode quickly. And finally, specific heat, 100, 230, and the thermal expansion, 100, 135. So this table gives, I think, a clear view on the differences of properties of these two metals, resulting, and this is the next slide, in pros and cons of copper versus aluminum. Well, let's start with the pros. A higher electrical conductivity, that's obvious. Copper has a lower resistance and a higher conductivity. That also results in a smaller radial size. For the same resistance, the copper conductor has a smaller size than aluminum. Mechanically, it's stronger. It has a lower degree of expansion. It's more flexible, easier soldering, a lower degree of oxidation. Copper oxide layer is conductive, as aluminum oxide layer is insulating. This is a major difference. Copper is not oxidizing so quickly, but when there is an oxide layer, it has the same nature as the basic material. And finally, a higher fatigue resistance for copper compared to aluminum. What is a con? We are talking only about technical now. The con is that it's heavier in weight. Sometimes it can also be explained as an advantage, but in many cases it's considered to be a disadvantage that copper is heavier than aluminum. Let's now say a few words. We have not that much time, but let's say a few words about failure mechanisms in which the material of the conductor plays a role. We start with aluminum. There is in the literature information given about the chemical reaction between water and aluminum. When water enters the conductor, then you get aluminum oxide and hydrogen. Hydrogen is developed in that process, and that can be at relatively high pressures, damaging joint structures and resulting finally into failure. This mechanism is not generally recognized as, and we will discuss that later, as not all utilities have in their statistics the relation, the link with the conductor material. So when there is a failure, it is not always recognized, is it in a copper or in an aluminum conductor. But in the literature, some laboratory experiments are described that indicate clearly that this is a threatening failure mechanism. Secondly, the oxide layer on aluminum by corrosion. Well-known, aluminum oxidizes very quickly when it's exposed to air, and it gets a thin layer of an insulating material that increases the resistance, and that can result also in problems finally resulting into a failure. Thirdly, the thermomechanical failure due to the mechanical properties. The coefficient of expansion, I showed you that in the previous slide, is higher for aluminum than for copper. That means when you have thermal cycling in a cable, the aluminum conductor is expanding and contracting more than the copper. And that results in mechanical forces, particularly at the joint place. And that can also result in failures. In general, when there is a lot of expansion, you have a lot of thermomechanical forces, and that can be resulting into failures. Now looking to copper, we were not able to find a real or a clear threatening aging mechanism. Of course, copper is aging, but it's not resulting into serious effects resulting into failures. Well, these slides I showed you so far give an impression of the differences in material properties and also in the advantages and disadvantages of copper versus aluminum in conductors of cables. And as what you could see is that the advantages for copper are quite obvious. Now the second part of this presentation, and that's about the questionnaire for both low voltage and medium voltage cables and accessories. The questionnaire was sent to utilities, I think in 25 countries, and the number of utilities was about 100. And we asked them to comment on the following 12 issues, which I will discuss with you. Can you give a score from 1 to 5? What of these 12 has for your decision a major influence to select copper or aluminum? If it's on the price, then you must give it a 5 for the price. If you do it because the radial size, you like to be as small as possible. So you can give a choice based on these 12 factors and then give a score from 1 to 5. We also ask the utilities to indicate which is your preferred conductor material. Well, let's look to these 12 factors. First, the price. It's obvious that the price plays a part, and I will discuss that later with you. The price is for aluminum lower than copper, and for many utilities this is a major argument to select aluminum. The radial size. I showed you already that copper cables are usually have a smaller radius than aluminum, which can be an advantage, for instance, when you install them in ducts. The weight. Copper is heavier. It's considered to be a disadvantage, but sometimes for submarine cable it can be an advantage when the cable is a little heavier and has a more stable position on the bottom of the sea. The mechanical properties. I showed you the tensile strength, the coefficient of expansion. These are all relevant properties, and are you selecting a material based on mechanical properties? Easiness of accessory installation. Can you install easy or not? And that has to do with the connector. Some utilities have problems with connectors in aluminum conductor cables. Easiness of repair. When something has a repair, Can you do it easily or not? Cost of corrective maintenance. After a failure, you have to repair. We call that corrective maintenance. The company standards. The compatibility with the existing cable network. When you buy a new cable, many utilities prefer to have the same because it suits well with the existing network. Is there any environmental concern? When the copper has a lower resistivity, it's better for the environment. Expected problems with connectors. And finally, any other factor we have not listed yet. Well, these 12 factors were given to the utilities in that questionnaire, and we asked, give a score from 1 to 5, which property is very important for you or very unimportant. This questionnaire was sent to the following countries: Belgium, Brazil, 2 utilities, Denmark, 2 utilities, Germany, Netherlands, also 2 utilities, Poland, South Africa, 2 utilities, Spain, Switzerland, Thailand, Turkey, and Mexico. Of course, we would have loved to have more utilities that sent us their questionnaire, their completed questionnaire, but you have to be realistic. Many utilities get quite often questionnaires, and they are not always happy to fill in and to give all kinds of data to somebody else. So we're still happy with 16, although of course we would have loved to have more. In the following slides, the results will be given for both low voltage and medium voltage cable networks. We will give for the low voltage cable network the scores, and we give in table 3 the cable network for medium voltage scores, and in table 4 we give the order of scores for which was really number 1 and which was the last, and also in table 5 the same, but then for medium voltage. So in these following tables you get a lot of information, but I would like to focus on the results, and we have now to deal with all the details. Well, here you see in this table vertically the 12 factors, and horizontally you see the 16 utilities. You see B8 is missing, and also B15. And that is, these utilities answered, but we could not really use their results. They were not clear, and we had contact, but we preferred not to list them because it was more confusing than that it gives any clear indication. Well, you see, let's take the first row, for instance, one that was the price. You see, for aluminum, it was many utilities give a 5 when it's aluminum. There's also 1 5 for copper, which is surprising. 2 for 5, but if you give the summary at the end, the T, the total for aluminum, and the next row is the total for copper, then you see 44 is a very high score. So the conclusion is correct to say, well, the lower price for aluminum is an incentive to buy an aluminum conductor. When you look to the other scores, for instance, number 2 was the radial dimensions, and you see for aluminum this is rather low because aluminum is usually thicker than copper, so you are not buying, when you look for the radial dimensions aluminum, then you prefer the copper cable. Well, I will not go into detail with all these values because I made a summary in the next slide, and that's more easy to follow than to do it here in this large table. The next one is a similar situation, but then for medium voltage cable. And you see, again, for number 1, the total score for aluminum price is 48. That means the highest value. And for aluminum, for copper, the highest is number 6. And well, let's go to the next slide, and then we can explain more clearly what all these values mean. These are the decision makers, the conductor selection for low voltage cables, copper, and the other side is aluminum. And we put in 1 to 11, we deleted number 12 because we didn't get really important additional, so we had the 11 factors. And you see, for copper, the company standard for low voltage gives a high value, mechanical a high value, connectors high, but not very much differing. You see 26, 25, 24, 23, it's almost the same. But when you go down, you see the price that is low, 18, and the weight is even lower, 12. Then you go to aluminum, the price is on top, 44. Company standard is also high, 26. Compatibility, weight. And then you go at the bottom, then you see radial size scores low, which is obvious because the aluminum conductor has a higher size than the copper conductor. And then we go to the next one. That gives you the decision makers for the medium voltage cables. And they are not so much differing from the low voltage values. For copper, the mechanical properties, the connector, radial size, repair, accessory, is for many an incentive to select for copper. And then you go to the bottom, the price and the weight has a low value. For aluminum, the price is for many utilities a big incentive to select for aluminum. The company standards, that means the company says, we have now decided to use aluminum. Of course, this is a law and you have to obey. This gives a high value, or a relatively high value, 31. Compatibility is 27, mechanical is lower, 20, weight is lower. And at the bottom, you see radial size is, just as for the other one, the lowest value. Well, what can we learn from this? The following decision makers for both low voltage and medium voltage cables scored high. The technical decision makers mechanical and connector score a high for copper. As the decision makers price and company standard were high for aluminum. Which one scored low? The technical decision makers price and weight scored low for copper. As the decision makers repair and radial size scored low for aluminum. So the company standard seems to play a role for both copper and aluminum, which can be explained as in both situations. The company's strategy is decisive. Company says we are going to do this, and then everybody has to follow. So it's clear that for both materials, this strategy is an important point. Surprisingly, the environment does not seem to be a dominating issue. We expected more attention for the environment, but maybe it's hidden in the other things. It's difficult to be clear about this. So just to summarize this, the mechanical and connector issues, and we know that utilities suffered problems with connectors in relation to aluminum cable, have a preferred view for utilities to select copper. Price is for aluminum the highest value for the decision. Let's go to the opportunities and challenges for these two materials. Because of material properties, copper is better than aluminum in almost every situation. And I made two quotes from the well-known BRCC Electric Cables Handbook. The first one is, almost the only unsatisfactory feature of copper is the way the price fluctuates. And the second one, aluminum has become a replacement solely on the basis of cost. But nevertheless, aluminum is becoming an inevitable competitor. But we think copper should be promoted for the situations where it is superior in terms of improved practical use and higher operational reliability. The other thing we believe is that more work should be done to make the superiority visible and demonstrable. What are the challenges for copper? Well, situations that are suitable for copper are cables in ducts and conduits, because there the radial size is relevant. The bigger the cable, the less problems you have with pulling in. Cables in all kinds of flexible situations, because the bending becomes more difficult with increased radial dimensions. In submarine cables, because we learned that in submarine cables, the heavier cable has an advantage. It's more stable on the bottom of the sea, and it can enter the sea trends more easily when it has more weight. And finally, for extra high voltage cables, it's very high rating. There we see that almost entirely the copper conductor is selected because of the higher conductivity. And when you go for the extra high voltage cables, you have a thick cable because you have a lot of insulating material. Then you also make the conductor big, and the cable becomes very large in dimensions. So for extra high voltage cables, copper is a preferred conductor material. What are the conclusions of this brief presentation? At first, insufficient failure data seem to be available to indicate differences in reliability, copper conductor cables and aluminum conductor cable. And why is that? Well, firstly, utilities do not seem to collect failure data systematically or do not want to share the related information with other parties, as it is competition sensitive information. It's our impression that when you talk to somebody on the phone, you get easily information, or easily you get information. But when you ask to write it down, to send it without reliability, in no way, that is not accepted by management to give away these data on failure data. If utilities collect failure data, that is the second point, they do not distinguish between copper and aluminum conductor, and they do not consider the conductor contrary to insulation as a relevant issue with respect to the reliability. That is an important conclusion. The failure statistics deals with the selection of the insulating material, paper cable, XLPE insulated cable. These are all separated in the statistics, but not the conductor, because it is not seen as a relevant issue. And we wonder if this is correct. We think it should be a good idea to add in the failure statistics also the type of conductor, to be sure to find out if there is any correlation. Copper conductor cables are preferred technically because of lack of problems with connectors, easiness of installation, better mechanical properties, and smaller radial size. For that reason, there are still all copper utilities. These are utilities that say we only want to have copper conductor cables because it's better. However, we have to admit that their number is decreasing. Aluminum conductors are mainly selected for economical reasons. Additionally, advantages like lower weight and compatibility with existing cables are also mentioned in the questionnaire. The utility industry seems to be insufficiently aware of the technical superiority of copper and is more focused on initial cost. As the LCCA shows a minor difference between copper and aluminum, obviously a short-term view is more popular than a long-term view. Utilities are more focused on a lower initial price than to say, look, all the advantages can be calculated, and during the total life, copper is a better proposal, but still the short-term view is quite often dominating. Successful long-term testing according to the present standard is not a guarantee for undisturbed long life. as not all aging mechanisms are covered in present testing methods yet. Therefore, the present testing standards are almost continuously subjected to a review process by relevant experts within CGRE and IEC. So when you say, I buy aluminum conductor and I have carried out a long-term test, that says something about the reliability, but not everything. It's always possible that a certain mechanism is not fully included in the testing procedure, and it may cause problems. May I give the example of water treeing? Water treeing was discovered at the 70s, 80s of the last century, and it was absolutely, completely unknown. Nobody ever thought that this would be a threatening mechanism, that water in combination with electric stress could result in so many failures. But it happened, and now all the cables are tested to check if they are resistant to water tree formation or not. Although it was outside the scope of this work done so far, there are strong indications that copper, because of technical advantages, flexibility and weight, is preferred in submarine cables, being part of a huge and growing international market. Well, this is my presentation, and what I said, we had properties, we discussed them briefly. I told you about the questionnaire and what are the results of this questionnaire and what are my ideas about how to proceed. And at the end, I made 4 propositions, statements you could say. And later on we will ask you to give your opinion about these 4 propositions. First one is quite clear. I think copper has better electrical, mechanical and chemical properties than aluminum to be used as conductor materials in cables. I think I gave you enough evidence for this statement that the weight, maybe that's sometimes not an advantage, but all the others, electrical, mechanical and chemical, are in the advantage of copper. The current, now we go to proposition number 2, the current trend to use aluminum as conductor material in low voltage and medium voltage cables is mainly driven by short-term capex gains. And maybe you remember what I quoted from the BICC handbook. They said exactly the same, that aluminum is mostly selected because of cost. And this is a short-term capex view. In the long run, statement number 3, in the long run, copper offers the most economic solution from a life cycle costing perspective. It is not dealt with in this presentation, but we are preparing a paper for DNV-GL. This is a conference to be held next year, and there we will clearly report about life cycle and life cycle cost perspectives, and we will show you that copper is an excellent solution when you look to the total life cycle cost and not only the initial cost. Finally, statement number 4, I already referred to that, as aluminum is far more than copper involved in degradation processes, and I explained to you processes that are really threatening. It is recommendable to indicate the conductor material in failure statistics in order to get a view on if there is correlation, and if there is a correlation, then we must do something to improve the situation. Well, these are my 4 propositions, and Hans, I would like to ask you, could you give us some guidance how to give our opinion on these 4 statements? Thank you.